Hello everyone, welcome back to my channel. In this video, I'll be showing you the full solutions to the problems in the Algebra Reviewer I uploaded 2 days ago for math majors who will be taking the licensure examination for teachers this year. So the reviewer has 30 items or questions. If you have not taken the timed practice test uh, in the video I uploaded 2 days ago, I suggest that you take that first before viewing the solutions that will be shown in this video, so that you will be able to assess your knowledge of the subject. Okay, let's begin. We have question number 1. Which of the following is an irrational number? Alright, now what do we mean by irrational number? An irrational number cannot be expressed as a fraction of two integers. Okay? So, among the four options which cannot be expressed as a fraction of two integers, let's examine each option. Take note that 2 raised to 4 is the same as 2 times 2 times 2 times 2, or 16, right? And we know that 16 is the same as 16 over 1. It's even equal to 32 over 2. And take note, these are fractions of integers, right? So 2 raised to 4 is rational. Okay? How about square root of 121? Obviously, that is just 11. Correct? And 11 is the same as 11 over 1. It is even the same as 33 over 3, which are fractions, right? So square root of 121, or 11, is a rational number. Obviously, 2/3 is a fraction, so it's rational. Now pi is approximated by the number 3.14, but in reality there are infinitely many digits to the right of the digits 3, 1, 4, and in fact the digits of the value of pi is unending. Okay, so among the four, pi is irrational. You cannot express this one as a fraction of two integers. So the answer here is letter C. Alright, we have question number 2. Which of the following illustrates the distributive property for multiplication over addition? Obviously, letter A is commutative property of addition. Letter C is associative property of multiplication, and letter D is associative property of addition. So the answer here must be letter B. Okay, so if you notice, in the left hand side, we are multiplying A to the sum B plus C. So we are actually distributing A inside the parentheses, so that in the right hand side we now have A times B and A times C. Alright? So this is what we call the distributive property for multiplication over addition. Alright? So the answer is letter B. We have question number 3. If A is not equal to 0, then A raised to P over A raised to Q is equivalent to which quantity? This is actually a popular law of exponent wherein you are dividing two numbers with the same base. So if you are dividing two numbers with the same base, you just copy the same base and then subtract the exponent or the exponents. So what's the common base? Obviously, the common base is A. Now, if you subtract the exponents, you must have P minus Q. So the answer is letter A. Let's have question number 4. Which of the following numbers is the largest? Obviously, we can immediately eliminate options A and D because they are negative numbers, and we know that negative numbers are less than the positive number. So we immediately eliminate options A and D. Now we just have to compare options B and C. Now let's divide 22 by 7. Let's see what we will get. So this is 3, so this is 21. So 22 over 7 is the same as 3 and 1 over 7. Now, since you're allowed to use a calculator, you can just divide 22 by 7 immediately using your calculator. Now, square root of 5 is between 2 and 3, and in fact, it is approximately 2.2. Again, you can use your calculator to verify that. And obviously, 3 and 1 over 7 is greater than 2.2. So we conclude that 22 over 7 is the largest among the four numbers. So the answer is letter B. Let's have question number 5. Evaluate the expression 3x minus 2y minus 4z given that x equals 2, y equals negative 3, and z equals 5. So this is just simple substitution. Let me copy first the expression. So we have 3x minus 2y minus 4z. So if we substitute the values, we will get 3 times 2 minus 2 times negative 3 minus 4 times 5. Now let's simplify each part. So 3 times 2, that's 6. Negative 2 times negative 3, that is positive 6. Negative 4 times 5, that's negative 20. So we have 12 minus 20, which is equal to negative 8. Alright, so the answer is letter D. Let's have question number 6. Simplify the fraction 15 plus 3 times 2 all over 9 minus 4 divided by 2. Now notice that if you have a series, or recall that if you have a series of operations, the most common method that we apply is the PEMDAS or the GEMDAS, right? And according to the PEMDAS or GEMDAS, so let me write first, or GEMDAS, you simplify first those numbers inside a pair parenthesis, or those numbers inside grouping symbols. Alright, so the P stands for parenthesis, G stands for grouping symbols. And then if there are numbers with exponents, so that's E, exponent or exponents, those are the numbers that you should simplify next. Then after simplifying those numbers with exponents, if there are multiplications of numbers, you simplify them next, okay? And then followed by division, followed by addition, and then subtraction. So there's an order in which we can simplify the operation. Now if you look at the numerator, we have an addition and a multiplication. So we multiply first 3 and 2 before we add. So we have 15 plus 3 times 2, that's 6, over. Now in the denominator, you have division. So take note, D comes first, comes before A, right? Or comes before subtraction or S. So we perform first division. So we have 9 minus. So negative 4 divided by 2, that's negative 2. So we have 9 minus 2. Now we can add and subtract. So 15 plus 6, that's 21. Over 9 minus 2, that is 7. So 21 over 7, that is 3. So the answer is letter A. Alright, let's have question number 7. So here we will apply the laws of exponents. Okay, now since the exponents are very small, we can directly simplify the numbers instead of applying the laws of exponents. But you can still apply the laws of exponents if you want. Okay. Now the part with negative 2 raised to 3 means that we have to multiply negative 2 to itself 3 times. So this means that we have negative 2 times negative 2 times negative 2, which is equal to negative 8. So this fraction is the same as negative 8 times 2 raised to 3, that's positive 8 over 3 times. Now let's simplify 2 squared inside this one. 2 squared is 4. We still have an exponent of 2. And then 4 squared is 16. So we have negative 8 times 8 over 3 times 16. Now we can cancel. Take note that we can cancel 8 here. We can cancel 8 here. So we have a 2 here, right? But we also have a 2 on top because negative 8 is the same as negative 4 times 2. So we can cancel this also. So we're left with negative 4. So on top, we are left with negative 4. And at the bottom, we are left with 3. So the answer is negative 4 over 3. So that is letter C. You can easily verify that using your calculator. But it's always good to apply our skills in simplifying these types of or this type of expression. Alright, let's have question number 8. What is the degree of 7x cubed y squared minus 4x z raised to 5 plus 2x cubed y? Alright, so before we determine the degree of this, let's have a very short review of how we determine the degree of a constant, the degree of a certain variable, for example. So the degree of a constant is zero, okay? And the degree of a single variable with an exponent is equal to the exponent. For example, if you have, let's say, w raised to 10. So the degree of this is 10. Degree is 10. But what if there are two or more variables? For example, let's say p raised to 5, q raised to 3. You just add the degrees of the two. So the degree of p raised to 5 is 5. The degree of q raised to 3 is 3. So you just add 5 and 3. So the degree of p raised to 5, q raised to 3 is 8. Alright? Now we can determine the degree of the polynomial expression. So we will determine the degree of each term. And the highest degree of the three terms must be the degree of the entire polynomial expression. So we know that the degree of 7 is 0, the degree of x raised to 3 is 3, the degree of y raised to 2 is 2. We just add 3 and 2, that is 5. So the degree of this is 5. Similarly, we do the same procedure. The degree of this must be 1 plus 5, right? So that's 6. The degree of negative 4 is 0 because it's constant again. And lastly, this one, take note the exponent here is 1. So the degree of this term is 3 plus 1, that's 4. Now what's the highest among the three numbers? The highest is 6. So the degree of the entire thing, the entire polynomial expression, is 6. So the answer is letter D. Question number 9. The expression a minus b times a squared plus ab plus b squared is equivalent to which expression? If you really know the different algebraic identities, you can easily recognize that this is actually difference of cubes. Alright? So, difference of cubes, sometimes or even most of the time, books use variables x and y to show the difference of cubes. For example, x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. Okay, so this one, the right hand side, is exactly this expression. Alright, so this expression is actually equivalent to a cubed minus b cubed. So the answer is letter B. So it is always good to memorize some of the algebraic identities so that when you encounter expressions that resemble those identities, you can easily simplify. Okay. Now, what if the worst case scenario is that you forgot the identity? What will you do? You just have to distribute a to each of these terms, also negative b to each of these terms, and then simplify. You will get letter B. Alright, now let's have question number 10. What is the complete factored form of 9a squared minus 25b squared? Obviously, this is difference of squares because take note, if you still remember, difference of squares is given by x squared minus y squared is equal to x plus y times x minus y, or we can have x minus y. You can reverse the positions. You can have x minus y times x plus y if you want. Okay, so 9a squared, this one, is the same as 3a squared, and 25b squared is the same as 5b squared. So our x here is 3a, our y here is 5b. So obviously this one, so let me write this one here, can be factored into 3a plus 5b times 3a minus 5b. And that is exactly letter C. So the answer is letter C. So be careful with the switching of the constant. You might write letter B because if you will not be careful, take note, the writer of this question swapped the position of or the positions of 5 and 3. Okay, so it must be 3a minus 5b. Alright, now let's have question number 11. Simplify the complex fraction 1 over x plus 1 over 1 over x minus 1. Okay, so the most common way of solving this is by getting the LCD first. This is actually what most students do. Get the LCD. So let's do that, and then I'll show you a shorter way. So let me write first the given. Okay, so what's the LCD of the quantity on top? The LCD is x. So you have 1 plus x. And then in the denominator, the LCD is x also. So 1 minus x. Take note, if we are dividing fractions, we copy the first fraction and then we invert uh, the other fraction, the divisor. So we copy the first fraction and then invert, then multiply. So times x over 1 minus x. And then we can cancel x, cancel x. So the result is 1 plus x over 1 minus x. So obviously the answer is letter B. But let me show you a shorter way. Let me copy again the given. Alright. We can just multiply the whole thing by x over x. Why? Because if you multiply the whole thing by x over x, diba we distribute this? So after distributing, we will have a 1 plus x, and then we will also have here 1. Okay, so 1 minus x, which is the same thing as this. Okay, next question. How many trailing zeros does 0.02 raised to negative 1 have when simplified? What do you mean by trailing zeros? These are zeros at the tail, okay? In the tail of the number. So we will simplify this first. We have 0.02 raised to negative 1. Take note by the laws of exponents, this one is the same as 1 over 0.02. Now, you can easily divide this one using your calculator, but I will just show you the manual procedure of solving this. Take note that 0.02 is the same as the fraction 2 over 100. And 2 over 100 is 1 over 50. So we have 1 over 50. And this is the same as 1 times 50 over 1, right? So the simplified form of this is 50. So how many zeros are there? How many trailing zeros? There's only 1. So the answer is letter B. Okay, question number 13. Simplify the cube root of 8x raised to 3n divided by 27y raised to 6. Alright. Um, let's apply a particular property of radicals. If you can still remember, there's this property that if we have the nth root of a raised to m, it's the same as a raised to m raised to 1 over n. So you can actually remove the radical symbol or the radical sign, but you take note of the index, which is n. Okay, so it becomes a fraction at the end, and it becomes the exponent. Alright, so let me copy first the given. So we have the cube root of 8x raised to 3n divided by 27y raised to 6. Here the index is 3. So we can change the entire thing into 8x raised to 3n divided by 27 y raised to 6 raised to 1/3. Now, we can distribute 1/3 inside, but notice that we can actually change first 8 into 2 raised to 3 and 27 into 3 raised to 3, so that after we distribute the 1/3 inside, we can cancel some numbers. So we have 2 raised to 3 times x raised to 3n divided by 3 raised to 3 times y raised to 6. So now it's easier to simplify. So let's multiply the exponent 1/3 to each of the exponents inside. So 1/3 times 3, that's 1. So we have 2 raised to 1 already, times x raised to 3n raised to 1/3, so 3n times 1/3, so we have n over 3 times 1/3, that is 1, so 3 raised to 1, and 6 times 1/3, that is 2, so y raised to 2. And finally, the final answer is 2x raised to n over 3y squared, and that is letter C. Let's have question number 14. Simplify 2a raised to negative 1 plus a raised to 0 over a raised to negative 2. Alright, so a non-zero number raised to 0 is always equal to 1. So we know that a raised to 0 is equal to 1. And by the other laws of exponents, we can write 2a raised to negative 1 as 2 over a. And take note, a raised to 0 is already 1. We can also write a raised to negative 2 as 1 over a squared. Again, we are dividing an expression by a fraction. So we can copy the first expression. So 2 over a plus 1. And then invert the fraction below and then multiply to the first expression. So I will enclose this one by parentheses. And then 1 over a squared will become a squared over 1 because we invert it. That's just a squared, right? Now, let us distribute a squared inside. So we have 2 over a times a squared plus 1 times a squared. So we can cancel the a here. So we have 2a plus a squared. Alright, so the answer is letter B. Okay, question number 15. Simplify the cube root of square root of 256. It might be tempting to multiply the indices of the radicals. Take note the index of the square root of 256 is 2. But it's easier actually to simplify first the square root inside, because we know that the square root of 256 is just 16. So we can write this one as cube root of 16. And take note, the index here is 3. So let's write 16 as a product of a number that has exponent 3 and some extra factors. Okay, so this is actually the same as the cube root of 8, or 2 raised to 3 times 2. Okay, 2 raised to 3 is 8 times 2, that's 16. And now we apply again properties of radicals. So we can separate these two factors into cube root of 2 raised to 3 times the cube root of 2. So we cancel the index and the exponent. So the final answer now is 2 cube root of 2. So the answer is letter A. Let's have question number 16. Suppose x varies directly as y squared and inversely as z. The constant proportionality in terms of x, y, and z is equal to which quantity? Alright, now we don't have a given symbol or notation for the constant of proportionality, but in most books we use k, right? So let us use k to represent the constant of proportionality. Okay, so if we translate the first sentence into a mathematical equation, we will have x equals k y squared divided by z. So why do we have this form? Because it says here varies directly. So k times y squared. And the second part varies inversely as z. So z must be in the denominator. Now we are told to find the equivalent expression for the constant of proportionality k. So let's solve for k in this equation. We can multiply both sides by z to get xz equals k y squared. And finally, we can divide both sides by y, or y squared. Y squared. So cancel na. Okay, so we have xz over yz equals k. So what is the answer? The answer is letter. No. This must be 2. I'm sorry. So let us repeat this. So this must be y squared, not z. So this is y squared. So the answer is letter D. Question number 17. Two brothers are respectively 5 and 8 years old. In how many years will the ratio of their ages be 3 is to 4. Okay, so we don't know the number of years that we will pass in order for the ratio to be 3 is to 4. So let x be the number of years. Okay? So let x be equal to number of years. So after x years, their ages will be 5 plus x. Okay, 5 plus x. And the other one is 8 plus x. So by that time, the ratio of their ages will be 3 is to 4. So if you divide 5 plus x by 8 plus x, 5 plus x divided by 8 plus x, the result is 3 is to 4 or 3 over 4. Now, do not reverse the position because there's actually a clue in the given ratio. So the first number is smaller, right? So 3 is smaller than 4. So it follows that you must divide 5 plus x by 8 plus x and not the other way around. Now, if we cross multiply, we get 4 times 5 plus x equals 3 times 8 plus x. So this is going to be 20 plus 4x equals 24 plus 3x. Let's transpose 3x and 20. So we have 4x minus 3x equals 24 minus 20. So the final answer is x equals 4. So after 4 years, the ratio of their ages will be 3 is to 4. So the answer is letter B. Let's have question number 18. If 8 men take 12 days to assemble 16 machines, how many days will it take 15 men to assemble 50 machines? Now let's analyze first the relationship between variables here. Take note that there is an inverse relationship between the number of men and the number of days, while there is a direct relationship between the number of men and the number of machines made or assembled, right? Now, from that, we can create a mathematical equation based on the concept of variation, direct and inverse variation. But first, let us represent the variables. So we capital M capital M be equal to the number of men. We also let small d be the number of days and small m be the number of machines assembled. Okay, this must be I. Okay, so machines assembled. So what equation can we have? Now let k be the constant of variation. Constant of variation or proportionality. Alright. So what equation can we have now? Take note again, there is an inverse relationship between the number of men and the number of days, but there is a direct relationship, direct variation type of relationship between the number of men and the number of machines assembled. So our equation will be capital M equals K times the number of machines assembled, uh, denoted by small m, and then the entire thing over the number of days. Okay, now take note there are two parts in the question. So the first half of the question gives you a complete set of information for capital M, and small d. So we can use these values in the first half of the equation to solve for the value of k. So here, let us list down first the values to avoid confusion. So capital M is 8, small m is 16, and small d is 12. Now let's solve for k. We can substitute this value, so we have 8 equals k times 16 divided by 12. Okay, now cross multiply and then divide by 16. We will get k equals 8 times 12 divided by 16. Alright, so 8 over 16, that's 1 half. 1 half times 12, that is 6. So we know the constant is 6. Now let's go to the second half of the question. Let me divide this area. Take note, the constant is 6. Now the question is, how many days will it take 15 men to assemble 50 machines? So here the value of m increased to 15, value of capital M. Now the value of small m is 50, and we are finding the number of days it will take the 15 men to assemble 50 machines. So this is what we are looking for. We will use again this equation. So we have capital M 15 equals constant, which is 6, times small m, which is 50, over number of days. Cross multiply and then divide by 15. You will get a d equals 6 times 50 over 15. You can easily verify this one using a calculator, but I'm just going to show the full solution. I'm going to um, break down 15 into 3 times 5 so that I can cancel. Alright, so I'll have here d equals 6 times 50 divided by 3 times 5. So we can cancel, right? So 6 divided by 3, that's 2. And then 50 divided by 5, that is 10. And 2 times 10, that is 20. So 20 days. That's letter C. Next. What is the range of the relation 1, 3, 2, 6, 3, 9, 4, 12? So if you are given with a set of ordered pairs and if you're asked with the range of the relation, you just look at the y coordinates. What are the y coordinates here? We have 3, 6, 9, 12. But if you are asked about the domain, you look at the x coordinates. So here we look at the y coordinates because we are asked about the range. So the range consists of the numbers 3, 6, 9, and 12. So that is letter B. Question number 20. A square has an area A and a perimeter P. Express A in terms of P. Alright, let's draw a square. The perimeter is P. So what's the side length of the square? So if the perimeter is P, we just divide this by 4 to get the side length. So this side is P over 4. This one is also P over 4, P over 4, P over 4. Now we're asked to express the area A in terms of P. How do we get the area of a square? Side times side, right? So what's the side? P over 4. So A is equal to P over 4 times P over 4, which is equal to P squared over 16. And that is letter C. Next question. A man has 40 feet of wire fencing with which to form a rectangular garden. The fencing is to be used only on 3 sides of the garden, his house providing the 4th side. Okay, so one side of his house, let's say this one, will provide the fourth side, and then he will enclose a certain portion, a rectangular region with the wire fencing. So this is the structure of the garden. All right. So the question is, what is the maximum area which can be enclosed? So what's the maximum area that can be enclosed? So what's the total wire fencing? This one. So the total is 40. So if we represent this side by x, this one must also be x. And take note, again, the total is 40 feet. So how much material is left for the third side? 40 minus 2x. Now, we are talking about maximizing area. So let's create an equation for the area. So suppose the area is A. So the area is just the product of x and 40 minus x minus 2x, because this is a rectangle, so that's length times width, right? Now if we distribute x, we get a quadratic expression in the right hand side. So we have 40x minus 2x squared, right? And then let's rearrange. So this is negative 2x squared plus 40x. Take note, the leading coefficient of the quadratic expression in the right hand side is negative. So if you are going to graph this equation or function, it is a parabola that opens downward. So it really gives you the maximum area. So if you're going to graph this, so I will not make a Cartesian plane. This one is the vertex, right? And the vertex has coordinates hk. The k here is the maximum area of the garden. So how do we get k? There is a popular formula for k. If you can still remember, the formula for k is 4ac minus b squared over 4a. So what's a here? So we can just look at this. So 4 times negative 2. C is constant, but there's no constant, so this is 0 minus b, which is 40, divided by 4 times negative 2. Automatically this vanishes because this is 0. So we will have negative 40 squared over negative 8. And negative 40 squared is negative 1600. And then we divide this one by negative 8. So finally, we have 200 as the final answer. So 200 square feet is the maximum area which can be enclosed. So the answer is letter C. Alright, so let's have question number 22. The sum of two numbers is negative 4 and their difference is 6. What is the larger number? Okay, so let's use the second condition saying their difference is 6. We will use this condition to represent the numbers. So suppose that the smaller number is n and the larger number must be n plus 6, because their difference is 6. So the gap must be 6. So if the smaller number is n, the larger number must be n plus 6. Now we will use the first condition saying the sum of two numbers is negative 4 to create an equation. So if we add the two numbers or the two representations here, n plus 6, the result is negative 4. Simplifying, we have 2n plus 6 equals negative 4. 2n equals negative 6 minus 4, so this is negative 10. 2n equals negative 10. Divide by 2. The answer is, the value of n is negative 5. Take note, we are looking for the larger number. The larger number is n plus 6. So we substitute n equals negative 5 here. So negative 5 plus 6 equals positive 1. So the larger number is 1. Letter C. We have question number 23. 10 years ago, Jane was 4 times as old as Bianca. Now, she is only twice as old as Bianca. What is Jane's present age? Okay, so in my own opinion, the best way to solve most age problems is to create a table to organize the solution. So let's create a table, a two-column table, since there are only two conditions. Okay, so let's divide this into two columns and then two rows. So let's have the second column, the column for present age, and then the leftmost will be the column for their age 10 years, their ages 10 years ago. So age 10 years ago. Okay, so let's put uh, Jane in the first row and Bianca in the second row. Okay, so let us represent their present ages. Okay, so according to the second sentence, the present age, uh, Jane is only twice as old as Bianca. So the pronoun she here refers to Jane. So Jane is only twice as old as Bianca. So if we represent the present age of Bianca by x, then Jane's present age is 2x, right? Now, let's go back in time. So 10 years ago, Jane was 4 times as old as Bianca. So what's the age of Jane 10 years ago? We will just subtract 10 from 2x. So we have 2x minus 10. How about Bianca? The same. We subtract 10. So we have x minus 10. Now 10 years ago, Jane was 4 times as old as Bianca. So the expression 2x minus 10 is equal to 4 times x minus 10. Okay? So 10 years ago, Jane was 4 times as old as Bianca. So 2x minus 10 is equal to 4 times x minus 10. Now this will be our working equation. So let's distribute. So we're going to have 4x minus 40 in the right hand side. And then let's transpose 4x the left. So this is going to be minus 4x. Transpose negative 10 to the right. We have negative 40 plus 10 already. So this is going to be negative 2x equals negative 30. Let's divide by negative 2. So x is equal to 15. Take note, we are asked about Jane's present age, but we represent the present age of Jane with 2x, but x is equal to 15. So this is equal to 2 times 15, which is equal to 30 years old. So the answer is letter D. Alright, now let's have question number 24. Solve for y in the equation 1 over ay plus 1 over by equals 1 over c. Let me copy first the given 1 over by over 1 over c. Take note, there's a y in the first fraction. There's also a y in the second fraction. In fact, we can factor out 1 over y. So 1 over y times 1 over a plus 1 over b. And because we want to isolate y, since we are solving for y, Let's multiply both sides of this equation by cy to cancel c in the right hand side and to cancel y in the left hand side. So I'm going to multiply the right hand side by cy, also the left hand side by cy. So we can cancel the y here, cancel the c here. So we're going to have c times 1 over a plus 1 over b equals y. Now let's get the LCD first inside. This is AB. So this is going to be B plus A. Let's distribute C. So BC plus AC over AB equals Y. And we can actually rearrange the terms in the numerator to get AC plus BC over AB. And we get exactly letter A. So AC plus BC over AB. So the answer is letter A. Next question. What is the intercept form of 4x minus 3y equals 12? So what do you mean by intercept form? So there are many forms of the equation of a line. So one of them is the intercept form. So how does it look like? So the intercept form is given by x over a plus y over b equals 1. So what are a and b? A is the x-intercept and b is the y-intercept. So obviously we can easily express the given 4x minus 3y equals 12 in this form by dividing both sides by 12. Why 12? Because if you look at this one, the right hand side is 1. So obviously that suggests that we have to divide both sides by 12. So the right hand side is going to be 1. We can cancel 4. So the first term in the left hand side is x over 3 minus cancel 3. We have minus y over 4. However, we need a positive sign in the middle. So how do we do that? The left hand side of this last equation is the same as x over 3 plus y over negative 4. Alright, so our a here is 3, our b here is negative 4. So obviously the answer is letter D. Next question. If x squared minus 6x minus 2 equals 0, what is the value of the square of x minus 3? Alright, so the form of the given expression is actually a perfect square, right? So that suggests that we must try completing the square of the left hand side. Okay, so let's copy first. So let's complete the square in the left hand side, but let's transpose first negative 2 to the right. So we have x squared minus 6x equals positive 2. Now, how do we complete the square in the left hand side? You take negative 6, the linear term, and get the coefficient, which is negative 6. Divide this one by 2, always, and then square. So this is going to be negative 3 squared, which is equal to 9. So we're going to add 9 to both sides. And obviously the left hand side is the same as x minus 3 squared. So 2 plus 9 is 11. And this is our final answer, 11. So that's letter D. Question number 27. The discriminant of a particular quadratic equation is 4. Then the roots of the quadratic equation are blank. Alright. I'm going to show a different way to analyze this. This is a common question in standard books in algebra. But I'm going to show a different way to analyze this one. Now, let's recall first the quadratic formula. Take note, the quadratic formula is given by x equals negative b plus minus the square root of b squared minus 4ac all divided by 2a. So what's the use of the quadratic formula? We can actually use the quadratic formula to solve for the roots of a quadratic equation. Okay? Now, the expression under the radical is what we call the discriminant of the quadratic equation. This b squared minus 4ac is what we call the discriminant. Okay, so let me circle that. So we call that one discriminant. Okay, now according to the question, the discriminant of a certain quadratic equation is 4. So let's replace this expression by 4. So we're going to have x equals negative b plus minus the square root of 4 over 2a. Square root of 4 is 2. So x equals negative b plus minus 2 divided by 2a. So there are two roots, right? The first one is negative b plus 2 over 2a. And the second one is negative b minus 2 over 2a. Obviously, these two expressions are not equal. Why? Because you look at this. This is positive, this is negative. The denominators are the same, but the numerators are not equal. So, obviously, these two fractions are different from one another. So, the two roots are unequal. So, automatically, we can eliminate letter B and letter D. Because obviously, um, we can eliminate D because obviously, these two quantities are real numbers. Alright? Real numbers. Now, what other characteristics do we observe? They are fractions, right? So they are rational. So we eliminate letter C because it says here irrational. So eliminate letter C. Take note, again, these are real numbers. So the answer is letter A. Question number 28. How many real roots does x raised to 4 minus 3x squared minus 10 equals 0 have? Okay, let's try to solve this equation and see how many roots it has and what kind of roots are these. Okay, so we have x raised to 4 minus 3x squared minus 10 equals 0. This is obviously factorable. This is going to be x squared uh, minus 5 x squared plus 2. So this means that either x squared minus 5 equals 0 or x squared plus 2 equals 0. Let's solve the first equation. So x squared equals 5. So if we're going to extract the square root of both sides, we're going to get x equals plus minus square root of 5. Similarly, we have here x squared equals negative 2. Get the square root of both sides. X equals plus minus the square root of negative 2. Take note, we have a negative number under square root symbol. So this is actually an imaginary number. Take note also that I squared is equal to negative 1. So I is an imaginary number. So this is going to be x equals plus minus the square root of 2i squared, or simply plus minus I square root of 2. So obviously there are four roots, but this one these roots here, positive I square root of 2 and negative I square root of 2, are imaginary numbers. They are not real roots, right? However, the other two roots, positive square root of 5 and negative square root of 5, are real numbers. So there are only two real roots of this equation. So the answer is letter B. Let's have question number 29. The hypotenuse of a right triangle is 34 inches. Find the length of the longer leg if one leg is 14 inches longer than the other leg. Now let's create a right triangle first. So this is the longer leg, shorter. So this is 34 units or 34 inches. Let's represent the shorter leg by x. And so the longer leg is x plus 14. By the Pythagorean theorem, we have the equation x squared plus x plus 14 squared, and then that's equal to 34 squared. So we're going to expand. So the result will be what? The result is x squared plus 28x plus 196 equals 1156. Now let's combine like terms. This is 2x squared plus 28x. So if we're going to subtract 1156, we're going to get negative 960. Okay, so to make the number smaller, we can divide both sides by 2. So we have x squared plus 14x minus 480 equals 0. Okay, so this is a very large constant. We might have difficulty factoring. You might have difficulty factoring this, but your calculator can always help you. However, this one is actually factorable, and it's the same. It's equivalent to x plus 30 times x minus 16 equals 0. So you can easily verify that, which means that x equals negative 30 or x equals 16. Take note, x represents the length of the shorter side. So we must get the positive value of x. So discard the negative value, take x equals 16. But we are asked about the longer leg. Okay, so the longer leg is represented by x plus 14. So the longer leg is 16 plus 14, which is equal to 30. So 30 inches. That is letter C. We are now on the last item. Question number 30. A parabola has a focus at 3, 5 and directrix y equals 3. What are the coordinates of the vertex of the parabola? Okay, the focus of a parabola is always in its interior. Alright? Now, let us plot the focus and then graph also the directrix. So, let's create a Cartesian plane. So, let's say this is 3 here. Let's say this is 5 here. So, this is now the focus of the parabola. So, that's 3, 5, right? 3, 5. Let us also graph y equals 3. Okay, so let's say this is 3 here. So y equals 3 is this line. Okay. So this is the directrix. directrix y equals 3. Now, obviously the parabola opens upward because the directrix is horizontal, and because uh, the focus is always in the interior of the parabola, the vertex of the parabola must be between this point and the directrix. Now, if we draw the axis of symmetry of the parabola, it will always pass through the focus and intersects the directrix. What is the intersection of the directrix and the axis of symmetry? Obviously, that's 3, 3. Now, take note of this. The vertex of such a parabola is always between this point and the focus. And in fact, it is exactly the midpoint of the segment connecting this point and the focus. Now, what's the midpoint of this segment? Obviously, it is 3, 4. So this is now your vertex. So the appearance or your parabola looks like this. We don't know whether it intersects here. What's important is we know the direction of the parabola. So the vertex is at 3, 4. So the answer is letter D. Alright, so if you find this video helpful, please like, share, and subscribe. Thanks for watching.